Here we meet the granddaddy of all antennas. What have we here? The box on the right is a signal generator. You can see a sine wave in the display. That's the type of varying voltage it is generating. There are two output terminals at the lower left of the signal generator. It is at these terminals that the time-varying sine wave voltage appears. Wires at these terminals are connected to the objects on the left that look like a couple of rods. And that's essentially what they are, two conductive metal rods connected to the signal generator. The current in a conductor is carried by the negatively charged electrons that are free to move about in the metal. Like charges repel, so if we make the top terminal negative, it will push electrons out through the wire and up through the top rod. If we make the bottom terminal positive, that will attract the negatively charged electrons upwards through the bottom rod, through the wire, and to the positive terminal of the signal generator. The sine wave voltage has now made the top terminal positive and the bottom terminal negative. This results in a net downward current of electrons through the two conductive rods. The gap between the conductive rods is effectively invisible to the overall current. It's as though there is only one rod and the current is flowing up and down in it. Here is the idealized gapless rod with the current flowing rhythmically up and down it, depending upon the signal generator voltage. The current flowing up and down in the rod at the frequency of the signal generator causes electromagnetic waves to be launched from the rod at the frequency of the signal generator. If we examine its antenna lobes, as we did with the dishes, we would see a pattern like this. You can see that the rod does not radiate the electromagnetic waves equally in all directions. The emission is strongest perpendicular to the rod, while there is zero emission parallel to the rod, so no electromagnetic waves issue from the top or bottom of the rod. The lobes surround the rod in a 360-degree pattern in the horizontal plane. Seen from above, it looks like a circle. The little dot in the middle is an end-on view of the metal rod. When we were looking at the antenna lobes from the side, the electromagnetic waves had that undulatory shape, but when seen from above, they're just straight lines. So I'll just draw some straight arrows to show that when viewed from above, the radiation pattern of the rod is equally good in all directions in the horizontal plane. The metal rod is a type of antenna known as a dipole antenna because it has two ends that are alternately positive and negative. Dipole antennas are important because they're easy to use and radiate in all directions equally well in the horizontal plane. Many other antennas can be thought of as assemblages of a lot of very tiny dipoles. Now that you know how dipole antennas work, you will be able to view the qualitative beamforming video with greater understanding.